So I want to bring that concept home a little bit more. So again, if we're talking about tangent of r, so let's say we're talking now about the tangent of r, then your eyeball has to be at angle r, okay? And so so opposite over adjacent would be like, well, it looks like ST is opposite from that point of view, right? And RT is adjacent. So the tangent of r would be ST over RT. Okay? And you can pause this presentation anytime you want if you ever want to go over anything. So that would be the tangent of r. But what if I was talking about the tangent of s? Oops, my hand sort of slipped there. So what if I was talking about the tangent of s? Okay, so then what I would do, kind of bear with me here for a second. Okay, then what I would do is I would have to move my eyeball over here. I'd have to go from this point of view. I'd have to have my eyeball at angle S. I know my eyeball just got larger, but so from that point of view, looks like RT is the opposite and ST is the adjacent. So tangent of S would be RT over ST. Okay? So remember, the important part that I'm trying to get across is that if it's tangent of A, then you have to have your eyeball at A. Or if it's tangent of R, you have to have your eyeball at R. Or if it's tangent of S, you have to have your eyeball at S. So it's whatever the angle is. Tangent of R, your eyeball's right there. Okay? Tangent of S, your eyeball would be right there. Oh, what happened? Tangent of B, let's see if I can do that again. Nope, I can't because I moved it over there. So tangent of B, your eyeball would be right there. Tangent of A, your eyeball would be right there. Okay, so that's a pretty important concept. Oh, maybe now I can do it. Hold on. Let me see if I can do that. Oh, hold on. So tangent of B would be right there. Having kind of a hard time making it move right now. But I think you get the point. Maybe if I make it larger. So yeah, so tangent of B, you would put your eyeball right here. Okay? And if it was the tangent, right there, and if it was the tangent of A that you're thinking about, that you're concerned about, then you would put your eyeball right there. Okay? And the other thing I wanted to kind of mention before we move on and see what kind of problems we can have is you're going to be discovering, learning more about your calculator. Your calculator is going to kind of open up to you a little bit more. Because on your calculator, you have a button that has a TAN. And tomorrow we're going to learn about cosine and sine. So you're going to have a little button that has a COS on it and a little button that has an SIN on it. And we're going to learn about what these buttons can do for us. We're going to learn how to use the tangent ratio on our calculator and the cosine ratio and the sine ratio tomorrow in lesson 7.6. So the use of our calculator is going to kind of expand. And after that, we'll learn 3 more buttons. So 6 buttons in all, I guess, we're going to learn over the course of a few days. And I think that's kind of fun, kind of exciting. Your calculator is going to become more useful and more powerful to you. And you're going to be in more control of more aspects of your calculator. Like I said, I think that's kind of fun and exciting. So, moving right along, let's look at what kinds of problems you'll be getting covering this concept. And first problem is find the tangent of J and the tangent of K. Round to 4 decimal places. So first one is to find the tangent of J. So I would put my eyeball at J, right? So here's my little eyeball. And so from the point of view of J, it appears to me, remember tangent is always opposite over adjacent, it appears to me that opposite would be 24 and adjacent would be 32. So, moving right along, the answer, tangent is always opposite over adjacent, and in relation to angle J, of course, my opposite over adjacent, like we just went over, is 24 over 32. So the tangent is 0.7500. Okay? And now the next problem is to find the tangent of K. So what I would do there is remember, it's always from the point of view of the angle in mind. So I'm trying to do angle K. Okay? So I have to put my eyeball there at K. And so from that point of view, it looks like opposite is 32 and adjacent is 24. Okay? So, moving right along, we have, again, tangent is always opposite over adjacent, but it's in relation to angle K. That's why my eyeball is there. And that would be then 32 over 24, and you get 1.3333. So that would be the tangent of K. Okay? So now problem 2 is where we know the angle. We know that this is a 61-degree angle, and we have to find the value of a missing side length, side here, which we're calling x. And we're going to round to the nearest 10th place. Okay? So the way we deal with this problem is the tangent of 61 degrees is equal to opposite over adjacent. Remember, tangent is always opposite over adjacent. And in this case, the tangent of 61 degrees, that's right there. So this is where I would put my eyeball. I'm going to spare you me drawing another eyeball, but remember, imagine yourself being a little tiny person, you're standing right there. So in relation to that, if you're standing right there, then this looks like the opposite. So 22 is your opposite, and x is your adjacent. Remember, this is your hypotenuse, and the hypotenuse is never the adjacent or the opposite. Hypotenuse is always just hypotenuse. Okay? So, moving right along, the tangent of 61, again, is opposite over adjacent, which in this case is 22 over x. And the tangent of 61 degrees, we went over in class how to do that. You use your calculator and you punch in the tangent of 61 degrees, and it always gives you the same number, which is 1.8040. If it gives you some strange number, by the way, if the tangent of 61 degrees did not give you 1.8040, you are probably in radians on your calculator, and you need to change radians to degrees. Anyway, the tangent of 61 degrees, no matter how large or small your triangle is always going to be 1.8040. So now you can see why I said it was an important concept. In the beginning of this lecture, I told you it's an important concept that the ratio of the lengths of the legs in a right triangle is constant or the same for any given angle measure. So for 61 degrees, we're always going to get that number for tangent. If that wasn't the case, then well, it wouldn't be useful. Trigonometric functions, trigonometric ratios rather, wouldn't give us a way to figure out missing angles and missing lengths. Anyway, so the tangent of 61 degrees is 1.8040. So the rest of this is just basic algebra trying to solve for x, right? So then we have multiplying both sides by x. Like in other words, if I took this multiplied by x and this multiplied by x, then x divided by x is 1. That's why you just get the 22 there. And then on this side we'd have 1.8040 times x. So that's where that came from. Multiplying both sides by x, you get that. And then dividing both sides by 1.8040 so that I can get the x all by itself. The answer is x is equal to 22 divided by 1.8040, and that is 12.2. So the missing value of x is 12.2. This is 12.2 long, okay, 12.2 units long. So that's the end of 7.5 lectures. It's on the tangent ratio. Tomorrow we're going to go over 2 more trigonometric ratios, cosine and sine. As usual, if you have any questions or concerns, please feel free to contact me at your convenience, and I would love to help you out. Okay, bye-bye.